Section 5, the normal distribution. So this starts to get into a little bit more advanced statistics. So if you take a statistics course, you'll definitely have to know this, but then you'll have to know much more deeper probability stuff. So for this, we're just going to study the normal curve and the empirical rule. So normal distribution is a probability distribution. It is the most common distribution in statistics, and it's used to make predictions about a population from a sample. So remember, that's our inferential statistics is when we're making predictions, which we don't get into a whole lot here, but I think it is nice to study the empirical rule. So what are the properties of a normal distribution? Well, it's bell-shaped, as you can see in the picture below. The center in the distribution is the mean, and the spread of the distribution is based on the standard deviation. The mean, median, mode are all the same. It is symmetric. 50% of the area is above the mean and 50% is below. The total area under the curve is 100%. Can't go over, can't be under. And the highest point on the curve is the mean. So the empirical rule is a way of distributing the data. It doesn't cover everything, but a lot of questions can be covered by using the empirical rule. So there's a nice picture of what's going on with the empirical rule. I'm going to use some highlighters and some colors here. Your middle 68%, or the middle sections, middle two sections of the graph represents 68%. And of course, half of 68 is 34, so we can label each section with 34%. And that's going one standard deviation away from the mean. So one below, one over. That's what the mu minus 1. Oh yeah, you guys don't know what sigma is. Or you might not. Sigma is standard deviation. So mu is your mean. And you're going to do 3 standard deviations on the right and 3 standard deviations on the left. So if you just go 1 standard deviation away, that's 68%. But if you go 2 standard deviations away, now you're at 95%. So most of your data lies within 2 standard deviations if you have a normal distribution. And then if you go 3 standard deviations away, you're up at 99.7% of the data. So nearly all of the data is 3 standard deviations away. And then you just have your little 0.15% on the end there. And I know that it can be a little overwhelming when you're first looking at it. So definitely putting the empirical rule on your cheat sheet for exams is a great idea. Maybe if we do an example, it'll make a little bit more sense. We have age of retirement for NFL players. It's normally distributed, which means you can make this bell curve. With a mean of 33, so I want to pop 33 in the middle. And standard deviation of 2. So I'm going to say mu equals 33. Standard deviation equals 2. That's mean and standard deviation. And then I'm just going to fill in all the little dashes. So I always start to the right. I don't know why, but I want to keep adding 2. So 33 plus 2 is 35. Plus 2 again, 37. And then 39. So you only have to go 3 to the right. And then on the left, we have to subtract. So 33 minus 2 is 31, and then 29 and 27. And then if you'd like, you can draw all the little sections. So the middle two sections, that's where your 68% is. So each one is 34%. And it might be helpful to shade it in. All right, and then your next section, these each have 13.5%. And I'll shade those in. And then the next one is 2.35%. Okay, and I'll shade, I don't have much room here, but I'll shade those in. So I should have everything I need now to answer the questions. I haven't even looked at the questions, but generally you need to at least calculate what all the little numbers will be, starting with the mean in the middle. So 95% of the players retire between what two ages? So if you go back up here, 95% stretches down to between the 13.5 and 2.35. So we just need to look 2 standard deviations to the left and the right. So I'm going to highlight those. That would be 1, 2 on the left is 29. 1, 2 on the right would be 37. So we just want to say 29 to 37 years. What percent of NFL players retire between 27 and 39 years? So I'll grab a highlighter again, different color, 27 and 39. Yeah. So those are both 3 standard deviations away from the mean. And if we go back up and look at our picture here, when you're 3 standard deviations away from the mean, that constitutes 99.7%. So you don't have to add up all those percentages. That is one that's already given to you. And then what percent of NFL players retire before they are 31? So that would mean less than 31 years old. Oh, I forgot to put in the 0.15 here. I'm going to put it kind of off on the side so I can actually read it. So we can just add, right? You can add up all the percentages before 31. And that would be 0.15 plus 2.35 plus 13.5. I should have percentages on all these. So I'm going to use my calculator and sum that up. 0.15 plus 2.35 plus 13.5. And that is 16% are retiring before they're 31 years old. All right, what percent of NFL players retire after they are 39 years old? So that means above 39, which is just this very small area of 0.15%. And what percent of NFL players retire between 27 and 35? So I'm just gonna use maybe red to kind of highlight. We're going from 27 to 35. All right, so I'm just gonna add those all up. We have 2.35% plus 13.5% plus 34%, and another 34%. So let's put that in the calculator and see what it is. I got 83.85%. 27 to 35, yeah. All right, well, hopefully that example makes it a little more approachable for you, but this is probably something that you're gonna have to watch a couple of times and do a couple of examples before it starts to make sense.